Lesson 6-3, Scatter Plots and Best Fit Lines, and in this lesson you learn to graph and interpret points on a scatter plot, to draw and write equations for best fit lines and make predictions by using those equations, and to solve problems using models. Okay, let's take a look at this example in education. Oh, before we do that, why is it important? Because you can use scatter plots to display data, examine trends, and make predictions. Now let's go back to this example on education. If you get a good score on your SAT, does that mean you have a good chance of graduating from college? The table below shows the average SAT, Scholastic Assessment Test, scores for freshmen at selected universities and the graduation rates for those. Okay, let me take that down. So you have these following scores: Baylor University in Texas, average SAT score is SAT score is 1045, graduation rate is 69%, and the data goes all the way down. Okay, Wake Forest University, average SAT score is 1250, 86% graduation rate. Okay, College of William and Mary in Virginia is 1240, average SAT score, 90% graduation rate, and so on and so forth. Okay. So with this example, let's see what we can do with this. Okay. So in this case, to determine if there is a relationship between SAT scores and graduation rates, we can display what we call, display the data points in a graph and what we call a scatter plot. So in a scatter plot, two sets of data are plotted as ordered pairs in a coordinate plane. In this example, the independent variable is the SAT score, and the dependent variable is the graduation rate. So that means if the independent variable is the SAT score, this will be your horizontal axis, and the dependent variable will be your vertical axis, which is the graduation rate. The scatter plot is shown at the left, this one right here. Okay, the graph indicates that the higher SAT scores do not necessarily result in higher graduation rates. And this is what we call a scatter plot of that particular set of data. Okay, so one way to solve real-world problems is to use a model. Scatter plots are an excellent way to model real-life data, to observe patterns and trends. Okay, and let's take a look at this one. Look for a relationship between x and y in the graphs below. Remember, x is your independent variable and y is your dependent variable, and this is your scatter plot. There is a trend that seems to go up. So this type of scatter plot, okay, in this graph, x and y have a positive correlation. That is, the values are related in the same way as x increases, y increases. So as one variable increases, the other variable also increases. In this particular scatter plot right here, you know that it's trending, okay, from top to right, left to right, it's going down. So in this graph, it has a negative correlation. That is, as the values are related in opposite ways, meaning as x increases, y decreases, and vice versa. As x decreases, y increases. Okay, and if you notice in this scatter plot, there seems to be no correlation. Okay, in this case, x and y are not related and are said to be independent. So this is an independent scatter plot, meaning to say that their relationship has no correlation. Let's take a look at example number 1. Table below shows 13 of the fastest growing cities in the United States and their latitude and longitude. Okay. So this is the ranking. North latitude and west longitude is also indicated on the last two columns. Okay. So fastest growing cities, number 1 is Bakersfield, California. Okay. Number 2 is Fresno, California. Number 3 is Las Vegas, Nevada, and so on and so forth. Okay. So what is being asked of us? Draw one scatter plot to represent the correlation between rankings of the city's latitude and another to represent correlation between the rankings and the city's longitude. Is there a correlation between cities, locations, and their popularity? That is letter B. And let's look at letter A first. Okay, this is now the correlation between their longitude and ranking. Okay, and this is their correlation between their latitude and their ranking. what do you notice? Okay, on those two, that there seems to be, okay, both of the correlations are fairly weak. You cannot see a positive or a negative sloping scatter plot. Okay, however, the correlation between the rankings and latitude would be probably stronger because of how close those points in the data are. Okay, it is impossible to tell whether either correlation is positive or negative. Thus, we could say that there is a weak correlation between the city's location and popularity. So when you talk about this one, you cannot tell if it's positive or negative. There's a positive or negative correlation, but in this case, you have your data closer to each other, so there is a relatively weak correlation between them. Okay? And next one, you can use a scatter plot to make predictions. To help you do this, you can draw a line called a best fit line that passes close to most of the data points. Use a ruler to draw a line that is close to most of all the points. Then use the ordered pairs representing points in the line to make predictions. Okay, so we call this a best fit line. So how do we do this? Okay, a best fit line shows if the correlation between two variables is strong or weak. The correlation is strong if the data points come close to or lie on the best fit line. Let me repeat that. So when you have a strong correlation, that means once you draw your best fit line, a lot of the points are close to or lie on the line. Okay, the correlation is weak if the data points do not come close to the line, and that's how you figure out if there's a strong or weak correlation. Okay, by using a best fit line. Let's talk about this. A lot of you have dogs, and this will probably clear up the age of a dog. Dogs age differently than humans do. You may have heard someone say that a dog ages 1 year for every 7 human years. However, that is not the case. The table to the right shows the relationship between dog years and human years. One dog year is 15 human years. 2 dog years is 24 human years. 3 dog years is 28, and so on and so forth. And if you notice, it's not a multiple of 7 every single time. So let's draw a scatter plot to model the data and determine what relationship, if any, exists in the data. Okay. Letter B, draw a best fit line for the scatter plot. And letter C, find an equation for the best fit line. Okay, let's do letter A. Let's create a scatter plot for the data what we have there. Let in the independent variable be dog years. Remember, time is always independent. And let the dependent variable be human years. Okay, since these are two time, the variables are both time, it is more logical to think that the dog years will be independent and the human years will be dependent to the dog years. And this is the scatter plot shown here. The plot seems to indicate that there is nearly a linear relationship between dog years and human years. Okay, there also appears to be a positive correlation between the two variables. Okay, as x increases, y increases. So there seems to be a positive correlation, because if you notice, that line seems to be going up. Okay, so that is there seems to be a positive correlation. And letter B, let's answer letter B. Draw a best fit line for the scatter plot. So if you are going to draw a best fit line, no line will pass through all of the data points. That is a fact. However, the best fit line describes the trend of the data. Draw a line that seems to represent the data. So if we are going to draw a line, this would be a nice line to draw. Okay, so you have a line that passes through a few of the points of the data, but not all of them. Okay, and the slope of the best fit line is positive. Thus the correlation between the two variables is also positive. So after drawing a best fit line right there, let's find the equation for that best fit line. Remember how to find the equation in the last lesson. You need to find 2 points to find the slope, and this is what we do. As you can see, the best fit line we drew passes through 3 of the data points. Okay, 4.2, 432, right there, 537, okay, and 642 right here. Okay, use 2 of these points to write an equation of a line. Remember how we do that. First things first. Okay, find the slope. So So we want to find the slope, okay? And let's do that. Well, can't undo that now. Okay, it appeared already. So our slope is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And we use the points 5 and 37, and 5 and 37, and 4 and 32, okay, as our x sub 1, y sub 1, x sub 2, y sub 2. Then we use the point slope form. Our slope is 5 in this particular case. So we use point slope form. That means we will substitute 5 to lowercase m and use either point y1 or y sub 1 or x sub 1, okay, as either 537 or 432. So in this case, we use the points 432, and we substituted the value for m, which is 5, which is the slope, okay? And we now have h minus 32 equals 5d minus 20 using the distributive property, okay? And then we put it into standard form by adding 32 to both sides and subtracting 5d to both sides, and then multiplying both sides by negative 1. So the steps that were not shown here is this, okay? So you have h minus 32 equals 5d minus 20. First thing we did was we added 32 to both sides, and we added 32 to both sides. We end up with h equals 5d plus 12, and then we subtracted 5d to both sides. We ended up with negative 5d plus h equals 12. But remember, in standard form, okay, the variable of our x coefficient, sorry, the variable of our x, okay, I'm sorry, the coefficient of the variable x, in this case it's letter d, should be positive. So we have to multiply both sides by negative 1, and that's how you got 5d minus h is equal to negative 12 right there. Okay? So from there, it's asking for letter D. Letter D is use the equation to determine how many years are compatible with 13 dog years. So let's look at letter D. Okay, if we use that to determine how many years are compatible with 13 dog years, let D be equal to 13 and solve for h. So basically what we do is get the value of 13 and then substitute it to our variable d. Okay, so 5d minus h equals negative 12. Substitute that to d. You have 5 times 13 minus h equals negative 12. And this becomes h equals 77. Why? Because 5 times 13 will give you 1565. Okay, and then we subtract 65 to both sides. Okay, and we subtract 65 to both sides and multiply both sides by negative 1. So if you notice, the steps that have not been shown here would be 65. Let me erase that properly. Okay, it will be 65 minus h is equal to negative 12. Then you subtract 65 to both sides. Negative h equals negative 77. Then you multiply both sides by negative 1. Okay, end up with h equals 77. So, if we let d be equal to 13, so if your dog is 13 years old, okay, the age in human years will be approximately 77 years old. Okay, and that's how you use your best fit line to be able to determine, okay, how old your dog is in human years when the dog is 13 years old. And that's the end of our lesson. The secret word for this one will be poodle. Secret word for this. Okay, take note of that secret word. And the last thing that we need to do for this lesson would be definition of a regression line is the most accurate best fit line for a set of data and can be determined with a graphing calculator or a computer. A graphing calculator assigns each regression line, okay, an R value, okay. So this value, negative 1 less than or equal to R, okay, and less than or equal to 1 measures how closely are related to each other. So -1 indicates a strong negative correlation, and +1 indicates a strong positive correlation. But then again, this is using a graphing calculator. This is just to let you know what a regression line is. So if you come across that word or the definition of that word, you know what it means. Okay, so it basically measures, okay, how closely the data are related to each other. So again, a -1 indicates a strong negative correlation, and a +1 indicates a strong positive correlation. Okay, and that's about it for this lesson. Okay, an additional one that I forgot to add. Okay, thank you for watching.